So good afternoon, everyone. My name is Janelle Edens, and I am the Advanced Reactor Development Team Lead within the Office of Nuclear Energy. So today I'm going to provide just a really brief overview of some of our advanced reactor research facilities that could be useful for CINR proposals. And I do want to point out that this is just a subset of the facilities that we have available, but the ones I'm going to present on today are the ones we thought would be most appropriate for a CINR project. And I've also included the contact information for the relevant subject matter experts at the labs on each of the slides. So feel free to contact the labs for any additional information on the facility or if you're interested in a partnership. But if you have specific questions on activities that you're planning to propose, then those types of questions would need to go to the general neop.gov email address. Okay, so first up, we have the Mechanisms Engineering Test Loop Facility, or METL, and this facility is at the Argonne National Lab. And METL is a liquid sodium test loop with about 3,000 kilograms of reactor-grade sodium in 4 vessels. And this facility has been supporting industry-identified fast reactor component testing since 2019. And as you can see on the slide, there are a number of test articles that are in various stages of design and testing. We have the gear test assembly and the gripper test article to test components of refueling machines that are going to be used in sodium fast reactors. And we've been testing the GTA since 2019, and the GRTA will be commissioned in 2025. Then we have Theta, which is a small mock-up of a pool-type SFR that's electrically heated. And the primary system has been installed in METL since 2021, and the secondary system is planned for completion in 2023. Then finally, we have F-star, which will replicate the outlet plenum and upper internal structure of an SFR to enable us to test flow sensors and other instrumentation. And we plan to start testing F-star in METL by 2024. So in terms of how METL could be used to support a CINR project, based on the $1 million funding level for the smaller NEOPs, it would be challenging to develop your own components for testing in METL. But something that you could consider would be improvements to METL, such as sensors or other instrumentation that could improve the performance of the facility or could lower the operating costs. And I did include a link to the METL website on the slide. So there's a really neat virtual tour that you can take if you're interested. Okay, so the next facility is the liquid salt test loop, and this is at the Oak Ridge National Lab. And this is the largest fluoride salt test loop that can be found within the DOE complex. And you can see the operating parameters for LSTL are listed here on the slide. And we're currently using this facility in our MSR research campaign to look at chemistry monitoring and control, species transport and off-gas monitoring, novel instrumentation testing, and generating data to support our modeling and simulation tools. Oh, I guess I need to click this slide again. We also list some examples of potential activities that could be supported through a NEA project. And I just want to add that this list is just meant to be some examples. It's certainly not all-inclusive. So we do encourage you to come up with any other creative uses that you may have. The next facility is the FASTER facility, which is also at Oak Ridge. And this is a chloride salt test loop. So again, the parameters for that salt loop are listed here on the slide, so you can determine whether this would meet the needs of your project. And this is a relatively new test loop at Oak Ridge that we would like to use in the future to support activities such as chemistry and corrosion control, system thermal hydraulics, digital twin demonstrations, and generating data to extend the life of materials. And again, we have listed, let me click again. We have listed some potential examples of the types of activities that could be supported through a NEA project. But again, this is not meant to be all-encompassing. It's just meant to spark some innovative ideas. Okay, the next few slides are going to cover some of our microreactor testing capabilities. And microreactors are a cross-cutting category of very small reactors that are being designed for non-traditional energy markets, such as off-grid communities, remote locations, military bases, and disaster relief missions. So we really do see microreactors as being essential to meeting our climate change goals. And these technologies are of very high interest to the Office of Nuclear Energy. And one of the cooling mechanisms that are being considered for microreactors is the heat pipe technology. So the Los Alamos National Lab has developed this eFill 37 capability, which is a scalable heat pipe charging and sealing apparatus. And this capability was developed to support automation of the manufacturing of heat pipe cooled microreactors. So this capability can be used to fill heat pipes that could be tested at universities as part of a NEAT project, or it also could be used to help train universities in filling heat pipes. And NE is very interested in this area of study since measuring heat pipe data is important for validation and licensing of heat pipe reactors. Okay, so the next facility is the CINR facility, which is located at the Idaho National Lab. And CINR provides capabilities to perform both steady state and transient testing of heat pipes and heat transfer. And CINR also allows for better understanding of thermal performance of heat pipes under a range of heating values and operating temperatures. So we expect that this facility will help to enhance the understanding of heat pipe startup and transient operation. So to give you some perspective on the type of testing that can be done in CINR, one potential experiment is determining the thermal conductivity in a gap through gap conductance testing. We're also planning to validate long-term operation and system durability, as well as test components made with additive manufacturing methods. The next facility on the list is the Magnet facility, which is a non-nuclear testbed for performance evaluation of microreactor design concepts. And Magnet uses electrical heated elements to simulate core thermal behavior, primary heat exchanger performance, and passive decay heat removal for heat pipe and gas-cooled microreactors. And some examples of how Magnet can be used include things like looking at heat transfer within microreactor components. It can also be used to look at structural performance of core structures, as well as support power conversion studies and evaluation of heat pipe performance and performance of integral heat exchangers. And both the Magnet and CINR facilities can be used as testbeds for low technical maturity instrumentation that require data to attain those higher technology readiness levels. And also, both of these facilities have been part of various CINR projects in the past. So the lab experts are looking forward to continuing collaborations with universities on these facilities. This next facility is not actually a standalone capability, but it's an expansion of the Magnet facility, which was added on last year. And the helium component test facility added the capability to Magnet to test reactor components in a high temperature, high pressure helium environment. It also added a preheated compressed air capability to Magnet to enable testing of helium to air heat exchangers. I believe this is the final microreactor slide, and it's focused on the MARVEL project. And MARVEL is a microreactor that is planned to be built at INL to serve as a unique nuclear test platform to demonstrate microreactor operations and end-use applications. And MARVEL will produce heat and power to a functional microgrid, which will demonstrate the first nuclear-powered microgrid in the US. We also expect that operation of MARVEL will result in lessons learned for commercial developers, And we'll also create momentum, champion rapid technology maturation, and engage the microreactor end user company directly. So currently, Marvel is planned for operation at the end of 2024. So the timing may not be perfectly ideal for an FY24 CINR project, but I did want to start introducing this capability to the university community because it's only planned to operate for 2 years. So if we remain on track to start Marvel up in December of 2024, then in late 24 or early 25, data from startup of the initial testing of Marvel will be available. So that data would include zero power physics testing, startup preparation, startup transient and steady state temperatures, coolant flow rates, core power, and Stirling engine performance. So that data is something that could potentially be used to inform a NEOP project. And I do want to caution that we are working towards starting Marvel up in December of 2024, but there's always a chance that the date could slip. So please keep that in mind if you're interested in incorporating Marvel into your project. So this is my last slide, and it's focused on the virtual testbed or VTB. And VTB serves as a repository for state-of-the-art reactor models to evaluate performance and safety of advanced reactors. And the repository hosts a wide variety of advanced reactor types, including molten salt reactors, high-temperature gas reactors, and sodium fast reactors. It also hosts a wide range of simulation types, such as high-fidelity steady-state simulations, multi-physics transients, and core performance models. So currently there are over 30 distinct advanced reactor models, and we plan to add even more models to the VTB soon. And those models, they primarily leverage NEAMS codes to enable multi-physics coupled simulations. We've also seen over 200 users just in the time that we've started tracking from last month. So you can see that this is a very important tool that's being used by a number of stakeholders, such as advanced reactor developers, the NRC, and the university community. So one example of an activity that could be achievable through a NEA project would be leveraging existing simulation tools of advanced reactors already hosted on the VTB. You could also consider developing new models to be hosted on VTB that could be used to support advanced reactor development and demonstration. And then additionally, upon completing any CINR project, we would encourage you to upload any new models to the VTB so that the wider community can benefit from it. So that was my last slide. Again, this was just a very brief summary of some of the advanced reactor research facilities that could be leveraged for NEA proposals. I do encourage you to contact the National for more information on these facilities. And I should also note here that none of these facilities are part of NSUF. So in order to use those facilities, you would need to partner with the appropriate national lab. And as a reminder, up to 20%, I believe, of NEOP funds can go to a non-university partner. So especially for the smaller NEOP projects, that could impact the type of activities that are supported in those facilities. And with that, I can take any questions.
Thank you so much, Janelle. We'll go ahead and move on to questions now.
So Janelle, there is a question from Lane Karasik. If we propose to use these test loops, but they are not sufficiently funded by DOE programs, how should we account for this in our proposals?
Right, so you would not account for the operating and maintenance costs in your proposals. That would be covered by DOE. And as far as we know, we have current plans to keep funding all of the facilities that were presented today. So the only thing that you would need to account for would be the cost for the actual test in the facility, as well as the time of the national lab experts that you would use.